Welcome and thank you for tuning in. Please subscribe to the channel so that you get all the videos that I upload. Please like the video and share the video. This video will take you through the introduction of arrays in C++. Arrays is one of the data structures defined or used in programming. So what is a data structure? So data structures are specialized formats used to organize, store, and modify data. There are two categories of data structures. There is linear data structures where elements are stored sequentially, and then you've got non-linear data structures where the elements are not stored sequentially. So the sequence is not guaranteed in non-linear data structures. Now for this video and the introduction of the array, it will be very simple and it will only look at the linear structure. So the examples of non-linear structures are not going to be looked at, but this is going to be specifically the array, and array is one of the linear data structures. Now I've given the definition in point form of what an array is here. So an array is a type of a linear data structure, as I've mentioned, right? It stores multiple elements under the same identifier. So before learning or knowing arrays, every time you want to store data, you would have used a variable. But if you wanted to store 10 separate numbers or strings or chars, whatever data you are looking to store, you'd have to use 10 variables. Now, with an array, you can store all those 10 variables in one variable, which is the same as one identifier. The elements are stored sequentially, of course, as we've said, that linear data structures, they guarantee sequential order. Then the elements that should be stored or stored in an array, they have to be the same type. You can't store a string and an integer in the same array. You have to store only one type. If you're storing integers, it should all be integers. If you're storing strings, it should all be strings. Then the elements are stored in consecutive memory addresses called indices. The size of an array is determined by the number of elements it stores. So that is the definition of what an array is. Now we have two types of array. We have one-dimensional array, which is the simplest and the one which I will focus on this video. And then we've got multi-dimensional arrays. This we will look at the end or on the next video. But once you understand the single dimension array, it is then very simple to understand the multi-dimensional array. So this is what an array looks like if you were to draw it out visually, right? You've got a collection. So an array is a collection of data, right? So I have drawn it in blocks to show you that it sort of looks like this. So what is inside, right? These are the elements, and then in this array, as you can see, I'm storing integers. So as I've said, that the data you're storing should be of the same type. So those are integers. And then I've tried to also just give an example of what the memory address would look like, right? Of course, that is in hex. Now, that is OX1, 2, 3, 4. So the memory addresses as well will be in consecutive order like that. Then you've got indices. Now, indices is a concept of arrays. This is a position where your elements are stored in the array. So the first element is in position 0 or index 0. The first element is in position 0. The second element is in position 1. And then in that sequence, and then the last element would be the array size minus 1. So here I've got 10 elements. So the last element is on the 9th position, because the position or the index of an array starts from 0. Now the size, of course, we said it is the number of elements, and then the positions, they start from 0 and they end at size minus 1, which is 9. Going to the syntax in C++ on how to declare an array. So an array simply needs the type of the data that you will store, right? You need the array name, which you will use, of course, as a reference to get to the memory where the elements are stored. And then you need the size, which is the number of elements that will be stored in that array. And then this is one of the disadvantages early of the array, that if you want to use a one-dimensional array, you have to know the number of elements you need to store beforehand. So you need to know the exact size or the exact elements that you will need to store in that array. Then you must define that before you use the array or before you declare the array. Then we go to the initialization part of the array. Now, how do we put in data into that array? So the first type, it would be after declaring your array, giving it a type, the name, and the size, you will then go for or write the assignment operator and then write your elements. Let's say now I wanted an array that will store integers. So I'm going to store integers. I will call it numbers instead. That's the name of my array, numbers. And then the size, I want to store 5 numbers. Assignment operator, those curly braces, and then I store 18, 19, 15, 12, and 8. That's how you would assign or store your numbers in that array. Now, all those are now assigned memory. They are stored in memory. And then to access them now, remember that starts at position 0, 1, 2, 3, and 4. So the last element is at size, which is 5 minus 1. So this will help you a lot when you are working with arrays, understanding that part there. And going back to the second one is array type, and then the name, array size. Then without using that assignment, you can just go for your curly braces and then write your elements and then end that. Then you've got the third one now, which is assigning each index to an element or the value, which is more like declaring a variable and then assigning the values separately. So now the example would be the same thing. Let's say I declared a integer numbers array of size 5. There, declaration done. So now for me to store the numbers, now I have 5 positions in memory, 1, 2, 3, 4, 5 to store my data. So now to store on the first or the 0th position, I would go numbers, and remember the positions start at 0, 0, and then assign it. Let's say now I want to assign it 22. Then 22 would be stored in position 0. And you can also, you don't have to store them in sequence, maybe go 1, 2, 3. You can even access the 4th position, which is the last position, right? And then assign it 50. Then that will be assigned 50, right? When you declare, of course, these will be all given default numbers, which you don't know, which I also don't know. But when you then assign it, it will override whatever was there. So then I think you get the idea now that when you maybe, so this should be numbers, and then on position 2, maybe I will store 100 there. So that, because this is 0, 1, 2, 3, 4. So on position 2, it will then store 100. And then on the flip side as well, that is how you then access your values in your array. You use the position. Let's say I wanted to display, and then to display in C++, use cout, those angle brackets, and then you would say numbers, and then position 2. That will then display 100 on your console or terminal. So moving forward, we have the concept of parallel arrays. Now this is a very interesting concept because let's assume or say you wanted to store data which has different types. Let's say you wanted to store learners in a class. You want to store their name and their age. So on that data you have names which are of type string, and you've got their age which are of type integer. Now you can't store those two types on a single array. Now the concept of parallel arrays comes from this problem here, or challenge. So parallel arrays, this is using multiple arrays to store data, and then each array contains a separate collection. So we'll have two collections of information. We'll have their names and we'll have their age. So that's what this point means. The arrays will have the same size. Of course, if there are 10 learners, you will need their names stored in 10 spaces. This will be their names, and then you will have their age stored, because each learner will have an age. If there is 10 here, there'll be 10 there. If there's 10 here, there'll be 10 here, vice versa. Then each corresponding index now of the arrays contain information. This is not complete. It contains information belonging to the specific record. Belonging to the specific record. So what that means is that, let's say we had 3 learners. We had maybe, let's say, Vuyo, who's 12 years old. We had John, who's 14 years old. Then we had Lerato, who's 18 years old. Now, that will obviously require 3 spaces. And then on the top one, I will then insert Vuyo and his age, or her age. That's 12. Then I have John and their age, which is 14. Then I have Lerato with the age, which is 18. Now look at that, now that for both arrays, the 0th position belongs to the same person. So this is how you can store different data types in arrays, and each index will represent a specific record. So John is 14 years old. That is the first position, and the Lerato is 18. That's the second. So this is like creating an array from 2 different arrays, because now you understand that at the 0th position, this is Vuyo's information. So when you want Vuyo's information, you go names at 0th position, and then you go age at 0th position. You know that this information belongs to the same person. It completes the same record, right? On the first position, it's John with their age, and then Lerato and the age. So that is how you would use parallel arrays to store different data types. Now, this was a very quick introduction to arrays. I want to then move on to the IDE and show you in code how to declare an array, how to assign an array, how to then access the information that is stored in an array. I will create a separate C++ file and call it arrays.cpp. So the extension of a C++ file has to be .cpp. A file already exists. Okay, I'll say arrays demo. So once that is there, since I'll be using cout, I will need the iostream libraries. So I will go #include iostream And so that I don't keep defining my namespaces when I see out, I'll just define that std namespace here, and then the main, of course, where your C++ code starts. And then once it is complete, because the function returns an int, you need to return an integer at the end. Now let us start with a simple basic one. So the first thing that we want to look at is declaring an array. So just a quick example of why an array is useful, right? Because that is important. Let's say you wanted to store numbers, right? Just numbers, whatever the numbers are, age, years, or whatever you are storing, but it's numbers. So you'll say int num1, let's say that is 10, and then int num2, that would be whatever number you choose, and then let's say there's 5 times. So I'm just going to duplicate that code. Say this is 136, this is 356, and the last one is 3. So you can see that you want to use 5 integers on whatever program you'll be writing. So you'll need 5 separate variables. And then if you obviously think about that, right, it is reasonable when it's a small number of integers that you want to use. Imagine now you wanted to use like 10,000 of these, or 1,000, or maybe let's just say 10. That's 10. Let's say 15, 1, 2, 3, 4, 5, 15, 20, 1, 2, 3, 4, 5. So you can see your code is getting bigger and bigger and bigger. So now with arrays, you can store all these numbers, 20 numbers, in just one single variable. So that is the importance of an array. That is where arrays become useful. You will not see it with small variables, but if you just extrapolate that to big numbers, you will then see the importance of them. But let us then, so if you obviously wanted to see out as well, it is the same thing. See out num1, num2, num3, num4, num5, right? You will then see your numbers. See out, let me quickly do that. Num1, space, and then I'll need to duplicate this. 3, 4, 5. 3 and 2. So with that output, we want to do the same thing using an array. So firstly, an array will eliminate all those variables, and you'll have one variable called numbers, right? You will then need to know the size, of course, beforehand, which is 5. And then once that is declared, there you have numbers. That should be 1M. Then it's up to you whether to assign these on the same line as declaration or separate. But for now, I will assign them on the same line, and I'll take the same numbers. And then as we said on the notes, curly braces, and then they should be comma separated. Comma, 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 and those are all integers. Now I've declared and assigned my values to this array. Now to display the numbers, now we will need a loop to iterate through all those. But the first part, maybe if you did not think about a loop, you can do it the same way. So you go numbers at index 0, that will give you 10. Numbers at index 1, that will give you 36. Numbers at index 3, that will give you 136. Numbers at index, I skipped 2, 3, and then numbers at 4, that will give you the last number. Remember, I said that the index or the position of an array starts from 0. So if you run now, this is the same code, but if you remember, it's a lot shorter now because of that one variable. Now this is hideous as well, because this could be written in a lot shorter format, right? Because again, if you want to see the impact and the usefulness of these collections, extrapolate the numbers, use maybe 10, 50 variables, and then convert them to a single variable, which is just one collection. Now that can be written in one line as well. So I'm going to keep that here as a reference. So you need a loop, any loop, to iterate through an array. So I will start from 0, since the positions start from 0. So I'll call this pause for position, start at 0. So I want to run from 0 to 4, right? Because that's the last position of an array. Now, this is pause must be less or equals to 4. And then we need to increment that, of course, for it to go from 0 to 4. So because now I have the index from the array, right? Let me just first see out pause so that you can see it. I will do it on the same line. So this will give you the positions. Now if I run this must give you 0 to 4. Okay. Now that, let me comment this one out. And then run once more. So these are your positions now. You have that 0, 1, 2, 3, 4, right? And it's coming with every iteration of that array. So all you need to do now is to say cout numbers, which is your array, and then the position, which is changing from 0 to 1. Then you just need to give a space to see the elements properly. And then if you run that now, it should give you the very same output that you saw here, right? So if you run that, there, 1036, 136, 356, and 3. So that is how you would initialize an array and also access your elements in the array. And then the second part, which I showed you, would be numbers. Let's say I just wanted to override one of those variables. Let's say the 100. I want to make sure that my arrays has numbers less than 100. So I will override the 1 in second position, because remember that's 0, 1, 2. So that will be 2, and then equals to, maybe let's say 56. Then I've got another one in position 3. Then that will be 3. Let's give that to 7. And then if you run now, you will see that these two are overridden by our new assignment in line 8 and 9. So this is the second way on how you can assign values or change values to your arrays. Then you'll see now that we have a different output. Instead of 166 and that 100, we have 56 and 7. Now there's the last way, which I want to test without the assignment. I know this works in Java. Let's see. The compiler is not complaining yet, so that should be fine as well. So if you run your code, this is now the third way of assigning an array in C++, right? As you can see, there's no assignment in between now. So those are the 3 ways you could declare and assign an array. Now let us say now this can be the age. Let's change that to 16, 13, 12. Let's give that 17. Yes. Let's say now this is the age, as I mentioned on this example of parallel arrays, right? Let's say there is an assignment or maybe a problem to say store our learners and their age, and then write a program that will give us the list, will output the list and their age next to their names. So you'll have one array which I will change to age, right? So that must change to age now. And then I'll have a second array which takes strings, right? This will be their names. It will also be 5 because there are 5 learners. And then I will use the first way of assigning. Then I will say I already had Vuyo, John, Lerato. So I will say Vuyo. And then I'll just duplicate that. So the second one would be John. That one would be Lerato. That one would be Obim. Fourth one would be me. That's the name, me. All right, there. Okay, that's autosave. It has saved it like this, but it's the same thing, right? So now when you run now, the first position, which is the 0th position, it represents Vuyo and their age, John and the age, Lerato and the age, Obim and the age, 17 and the age. So they must be stored on the same index, so that when you go to position 1 corresponds to John's age. Now to display that now, very easy, you go names here, and then you still put the position because everything is on the same position. So you say name, maybe a little string there in between, is space age years old, full stop, then end line, because we don't want to print them on the same line now. We want to end that line. And then when you run, you should see that now you'll print Vuyo is 10 years old, John is 16, Lerato is 13, Obim is 12, me is 17 years old. So you can see that on position 0, the 10 corresponds to Vuyo. So this is how now you can sort of like create conceptually a single array using 2 arrays, because you know that both arrays, each index corresponds to information that forms one record, right? Vuyo and 10 belong together, which is why they are both on the 0th position. So that when you use 0, it's both those 2 positions. How to use the size of an array in order to determine if you are going to run through the entire array, then there is a function in C++ that will give you the size of the array. So now, once you have that, instead of using 4 here, there's no need to hard code that. You can just get array size, then -1. So how you do that, you'd use the function size of, then pass your array, which is numbers or any of those, or which is age, or any of the 2, because they are the same size. Then -1, because remember, this is giving you the position of the array. What happened now? The bracket. This is giving you the position, right? Because if you say size and not subtract 1, that will go from 0 to 5, and there is no 5th element. So this is how you'd write the code dynamically instead of writing a 4 there, right? So that you know that when you change here to maybe 6, this will still work, because that will be 6 minus 1, which is 5. So that's how you would then write the code to access an array from the 0th position to the last position. So that is all on the introduction of array. I hope you understood and enjoyed the video. I'll catch you on the next one. Thank you.